In the cold reaches of the outer solar system, where sunlight fades to a dim golden haze and the void stretches silent and endless, Saturn reigns like a celestial jewel. This gas giant, the sixth planet from the Sun, has captivated human imagination for centuries, not just for its colossal size, its banded atmosphere, or its staggering array of moons, but for the brilliant halo that encircles it, its rings. These massive, icy structures, like a diadem of frozen lace, make Saturn the crown jewel of our planetary family. Yet as the year 2025 approaches, astronomers are preparing for a rare and somewhat sobering event. Saturn's rings are vanishing, from our point of view on Earth, and for a brief moment in cosmic time, the most iconic feature of the planet will disappear. The vanishing act is impermanent. Saturn's rings, as vast and radiant as they appear, will not physically dissolve in 2025. Instead, they will appear to fade from sight due to a cosmic dance as old as the solar system itself, a phenomenon called the ring plane crossing. This celestial alignment, where the rings tilt edge-on to Earth, occurs roughly every 14 to 15 years. When this happens, the thin profile of the rings becomes nearly invisible, a sliver of light too narrow and too faint to catch with the naked eye or even many telescopes. For a few weeks or months, Saturn will appear, to most observers, naked, stripped of the glory that makes it so distinct in the night sky. But this vanishing act is more than a visual curiosity. It's an opportunity, an astronomical event that allows scientists to probe Saturn's intricate ring system in ways they cannot when it's fully open. The rings, despite their grandeur, are incredibly thin, measuring only about 10 meters thick in some places, less than the height of a two-story house, while spanning hundreds of thousands of kilometers in width. This disproportion creates an illusion of solidity from afar. But during ring plane crossings, that illusion shatters, revealing the ephemeral, complex nature of the structure. To understand the ring's disappearance, one must first appreciate their origin and composition. Saturn's rings are composed mostly of ice particles, with a dash of rock and dust, varying in size from minuscule grains to boulders the size of houses. They orbit Saturn in near-perfect synchrony, tracing paths across the planet's equator, forming distinct bands, the A, B, and C rings, along with several smaller ones like the D, E, F, and G rings. Their origin remains a topic of intense debate. Some scientists believe the rings formed billions of years ago, possibly from the remnants of a shattered moon or a comet that wandered too close. Others argue that the rings are far younger, perhaps only a few 100 million years old, born during the age of dinosaurs on Earth. Their youthful luster suggests they haven't been around forever. Micrometeorites, solar radiation, and space debris would have dirtied and darkened the rings over billions of years. Instead, they remain dazzlingly bright, a clue that their birth may be more recent, and perhaps that their lifespan is fleeting. Indeed, some researchers now believe the rings are already dying, slowly but steadily raining down onto Saturn itself in a phenomenon known as ring rain. This gentle but inexorable process, detected by NASA's Cassini mission, suggests the rings may vanish entirely within the next 100 to 300 million years, a blink in the life of the solar system. But for now they remain, and in 2025, they will perform a cosmic sleight of hand, fading from view due to geometry rather than decay. The ring plane crossing happens because Saturn, like Earth, has an axial tilt, in its case about 26.7 degrees. As Saturn orbits the Sun over its 29.5-year journey, this tilt causes the orientation of the rings to change from our viewpoint. Sometimes we see them wide open, like the flared brim of a hat. Other times they seem to narrow, as if closing in on themselves. And then, precisely twice every orbit, they align edge-on, vanishing into near invisibility. The upcoming 2025 crossing will be the first such event since 2009, and it offers both challenges and wonders. For casual observers, the disappearance will be disappointing. Saturn, without its rings, loses much of its magic. Through a backyard telescope, it may appear little more than a striped sphere, no more remarkable than Jupiter's cloud bands or Mars' rust-red plains. But for astronomers, this alignment is a rare window into otherwise hidden phenomena. Moons normally lost in the glare of the rings become more visible. The vertical structure of the rings, including any warps, kinks, or waves, becomes easier to measure, and particles that hover above or below the main ring plane, like those in the faint D or G rings, can be more precisely tracked. Historically, these crossings have been moments of discovery. In the early 17th century, Galileo Galilei was among the first to observe Saturn's strange appendages through a telescope, describing them as ears or handles before they vanished, leaving him puzzled. It wasn't until Christian Huygens proposed the concept of a ring in 1655, and Giovanni Cassini identified multiple distinct rings decades later, that the mystery began to unravel. These early observations were only possible because the changing angles periodically obscured or highlighted different ring features, inadvertently helping astronomers understand what they were seeing. Today, with space telescopes and advanced imaging techniques, the ring plane crossing serves not just as a spectacle, but as a scientific tool. During the 1995 and 2009 crossings, astronomers used the Hubble Space Telescope and ground-based observatories to study the rings in infrared, ultraviolet, and radio wavelengths. These observations revealed new moons, faint ringlets, and the presence of meteoroid impacts on the ring's surfaces. Such impacts leave dark, transient streaks that are easier to spot when the rings are edge-on and their normally dazzling brightness is diminished. The 2025 event, scheduled to peak in March of that year, is expected to be the most precisely observed ring plane crossing in history. With more powerful telescopes, adaptive optics, and next-generation instruments, scientists hope to extract unprecedented data. The James Webb Space Telescope, if it turns its eye towards Saturn, could detect faint heat signatures and compositional details otherwise lost in the planet's glare. Radio observatories may capture fluctuations caused by passing dust or plasma, while optical telescopes can watch for new objects, tiny moonlets, that could be sculpting and shepherding the rings. But beyond the science lies the symbolism. The fading of Saturn's rings, even temporarily, reminds us of the impermanence of cosmic beauty. These rings are not eternal. They are not solid. They are not immutable. They are, like so much in the universe, dynamic, changing, vulnerable to the forces of gravity, time, and entropy. Their temporary vanishing in 2025 is a glimpse into a possible future, when millions of years from now, Saturn may orbit the Sun as a ringless world, its once majestic halo reduced to memory and myth. The upcoming crossing is also a reminder of our unique vantage point. From Earth, the alignment is precise enough to create this illusion of disappearance. From elsewhere in the solar system, from Mars or the moons of Jupiter, the rings might still appear in full, tilted differently against the backdrop of the stars. Our place in the cosmos, even our angle of vision, shapes what we see and understand. Just as the ancient astronomers once peered through rudimentary lenses and wondered at the changing face of Saturn, we too are part of a lineage of curiosity, always seeking, always watching, always marveling at the vast, elegant clockwork of the heavens. And so as 2025 draws near, sky watchers and scientists alike prepare to say a temporary farewell to Saturn's signature rings, not in sadness, but in awe. For even as they vanish, they reveal new truths. And like all things in space, their beauty lies not just in their appearance, but in their motion, their mystery, and their place in the grand story of the cosmos. As Saturn's rings slip toward invisibility in 2025, the scientific community prepares to unlock secrets hidden beneath their dazzling veneer. The phenomenon of the ring plane crossing is more than a mere spectacle of cosmic geometry. It is a rare experiment conducted by nature itself, offering a unique vantage point to study the fine structure, dynamics, and evolution of one of the solar system's most enigmatic features. Behind the scenes, telescopes across the world and in orbit ready their instruments, anticipating a flood of data that will deepen our understanding of the ring's composition, origin, and fate. At the heart of the mystery lies the ring's extraordinary thinness and complexity. While the rings span over 270,000 kilometers in diameter, they are astonishingly slim in the vertical dimension, averaging around 10 meters thick, comparable to a two-story building. This razor-thin nature means that when the rings align edge onto Earth, Their surface area visible to observers shrinks dramatically, reducing reflected sunlight and rendering the once brilliant structures nearly invisible to all but the most sensitive instruments. This thinness also makes the rings an ideal laboratory for exploring fundamental physics. The particles within the rings, composed primarily of water ice mixed with dust and rock, range in size from micrometers to meters, creating a vast population of orbiting icebergs, each interacting gravitationally and colliding with neighbors. These interactions create waves, wakes, and clumps that ripple through the rings like ocean currents frozen in time. When the rings appear face-on, their overwhelming brightness washes out subtle details. But during the ring plane crossing, astronomers can observe how the rings scatter light at different angles, revealing these small-scale structures. One of the most anticipated goals for 2025 is to map the vertical thickness of the rings in unprecedented detail. Though the rings are incredibly thin overall, localized perturbations, caused by gravitational tugs from Saturn's moons or collisions between particles, can create ripples and warps extending hundreds of meters above the main ring plane. Detecting these vertical structures is crucial for understanding the processes that maintain the ring's shape and prevent them from collapsing under their own gravity. Another fascinating aspect is the interplay between Saturn's rings and its magnetosphere, the region dominated by the planet's magnetic field. Charged particles trapped in this magnetic bubble constantly bombard the rings, slowly altering their chemistry and structure. The ring plane crossing allows astronomers to observe changes in the interaction between the rings and the charged particles from different viewing angles, which can help clarify how the magnetosphere influences ring dynamics and contributes to the ongoing ring rain, where ring material gradually falls into Saturn's atmosphere. The vanishing rings also offer a rare chance to spot faint, elusive moons that normally hide within the glare of the bright rings. Known as ring moons, these tiny satellites act as shepherds, their gravity shaping and maintaining the ring's edges and gaps. Some, like Pan and Daphnis, have been discovered only in the past few decades, thanks to close observations by NASA's Cassini spacecraft. During the 2025 crossing, astronomers will intensify their search for new moonlets and dust clumps, hoping to better understand how these small bodies influence ring stability and evolution. This event is a continuation of a scientific legacy carried by Cassini, which orbited Saturn from 2004 to 2017. Cassini transformed our knowledge of the rings, revealing their intricate patterns, their interactions with moons, and even uncovering the geysers of Enceladus, one of Saturn's icy satellites. The data collected by Cassini serve as a baseline for Earth-based and space telescopes to compare the ring's state during the 2025 crossing. By monitoring changes over time, scientists aim to answer pressing questions. Are the rings losing material faster than previously thought? How do meteoroid impacts alter the ring structure? What is the exact nature of the particles composing the rings? Moreover, the ring plane crossing is a natural experiment to test theories of planetary ring formation and longevity. Why do some planets, like Saturn, boast spectacular rings while others, like Jupiter or Uranus, have much fainter or more tenuous ring systems? Studying the vanishing rings helps unravel the delicate balance between formation, destruction, and renewal processes. For instance, the interplay between ring particles and Saturn's gravity may produce clumping and fragmentation cycles that replenish the rings intermittently, extending their lifespan. Beyond scientific instruments, the 2025 phenomenon draws attention to the observational power of amateur astronomers. Many ring plane crossings in the past have been documented by dedicated skywatchers equipped with modest telescopes. Their observations contribute valuable data points, particularly for transient phenomena like meteoroid impacts or temporary brightness changes. This collective effort between professionals and amateurs enriches our understanding and captures the excitement of witnessing a rare celestial event in real time. The vanishing rings of 2025 also provide a compelling example of how our perception of the universe is shaped by perspective. Just as the rings disappear from Earth's viewpoint, they continue to shine from other vantage points in the solar system. This subtle reminder of cosmic relativity illustrates that what we see depends profoundly on where and how we look. It reinforces a fundamental truth of astronomy. Our universe is a vast and dynamic place, full of wonders that shift and change with time and space. In a broader sense, this event sparks reflection on the nature of cosmic cycles. The rise and fall of Saturn's rings, their slow disappearance in the coming centuries, mirrors the life cycles of stars, galaxies, and even planets themselves. Nothing is static in the cosmos. Everything evolves. The rings remind us that beauty, no matter how grand, is transient, a fleeting expression of physical processes playing out over vast timescales. As the countdown to 2025 ticks closer, scientists, astronomers, and enthusiasts prepare not only to observe the ring's disappearance, but to decode the story that this rare alignment will reveal. Saturn's vanishing rings are not just a moment of loss. They are a portal to deeper knowledge, a testament to human curiosity and ingenuity, and a symbol of the ever-changing, ever-surprising universe we inhabit. The fleeting disappearance of Saturn's rings in 2025 marks a moment both scientific and poetic, a transient veil lifting to reveal deeper cosmic truths and humanity's enduring fascination with this giant planet. Yet, as the rings vanish from our view, questions arise about what the future holds for these majestic, icy bands and how their story intertwines with the broader narrative of our solar system's evolution. Saturn's rings, though dazzling and seemingly permanent from our vantage point, are in fact ephemeral features on a cosmic timeline. The elegant, shimmering bands are caught in an intricate balance, constantly shaped and reshaped by forces both internal and external. The process of ring rain, discovered by the Cassini mission, reveals that the rings are slowly losing material as charged water ice particles spiral inward, drawn by Saturn's gravity and magnetic field, ultimately disappearing into its atmosphere. This gentle but inevitable decay suggests the rings could vanish completely in as little as 100 to 300 million years, a blink of an eye compared to the 4.5 billion year age of the solar system. The ephemeral nature of Saturn's rings highlights the dynamic processes that govern planetary systems. Unlike the solid, rocky planets forged from ancient material, rings are fluid and ever-changing, shaped by collisions, gravitational perturbations, and the steady bombardment of micrometeoroids. These forces cause fragmentation and accretion cycles, sometimes creating temporary clumps or even small moons, while at other times eroding and spreading the ring particles thinly across space. Looking ahead beyond 2025, scientists envision future ring plane crossings as recurring opportunities to witness the subtle changes shaping Saturn's ring system. Each crossing offers a new perspective, different angles, different lighting, new data, allowing astronomers to track the slow erosion, detect transient events like meteoroid strikes, and observe the gravitational interplay between the rings and their shepherd moons. The ring's evolution is a living story, one that unfolds over decades and centuries, recorded in the light that reaches Earth. The ring's fate also serves as a powerful metaphor for change and impermanence in the cosmos. Just as civilizations rise and fall on Earth, celestial structures too are transient. The grandeur we see today is a snapshot, a brief chapter in the long tale of planetary formation and destruction. As the rings fade and eventually disappear, Saturn may become a quieter planet, more like Jupiter or Uranus, which possess faint, narrow rings that are almost ghostly in comparison. This transformation prompts reflection on the nature of cosmic beauty, not static and eternal, but fluid and fleeting, precious because it is temporary. Beyond the realm of science, Saturn's rings have captured human imagination for centuries, inspiring myths, art, and philosophy. Their vanishing in 2025 invites contemplation on humanity's place in the universe. They are a reminder that our perspective is limited and ever-shifting, that what we see depends on our position and moment in time. For the ancient sky watchers who first glimpsed Saturn's rings through crude telescopes, these features were mysterious and magical, sparking curiosity and wonder that continues to this day. The upcoming ring disappearance also resonates with modern storytelling and culture, symbolizing themes of loss, transformation, and renewal. As Saturn sheds its rings temporarily, it echoes life cycles of change, moments when something beloved fades away, only to re-emerge in new forms, or inspire deeper understanding. The event will likely inspire future generations of astronomers, poets, and dreamers to look up, to question, and to marvel at the grandeur of the cosmos. In practical terms, the 2025 phenomenon has invigorated public interest in planetary science and astronomy. Outreach programs, observatory events, and digital campaigns aim to share the wonder of Saturn's vanishing rings with a global audience. This event bridges the gap between cutting-edge research and everyday experience, reminding us that the universe's most profound stories can be seen with our own eyes, given the right moment and perspective. The technology developed to study the rings during the crossing, including advanced telescopes and imaging techniques, will also enhance our ability to explore other planetary systems. Lessons learned from Saturn's rings can be applied to understanding debris disks around distant stars, cosmic rings that hint at planet formation processes far beyond our own solar system. In this way, Saturn's rings become a cornerstone in the broader quest to understand how worlds and solar systems emerge, evolve, and sometimes fade. Ultimately, the 2025 ring plane crossing is a celebration of human curiosity and perseverance. It reminds us that even the grandest celestial spectacles are part of a dynamic, ever-changing universe. The temporary disappearance of Saturn's rings opens a door to discovery, inviting us to deepen our knowledge and expand our imagination. As the rings slip from view and then re-emerge in the coming years, they remind us that the cosmos is not a static backdrop, but a living, breathing story, a story that we are privileged to witness and tell.